Okay, guys, example 5. We're going to solve the same exact equation we did, or excuse me, the same exact system that we did in example 4, but now we're going to use the Gauss-Jordan elimination instead of the Gaussian elimination with a back substitution. Remember, if you watched the video that where I explained it, it's the same exact thing. You still need your ones in the diagonal. You still need zeros below it, but instead of not worrying about the numbers on top above the ones, Gauss-Jordan says that we have to, the elimination method says that we have to have zeros up there as well. Alright, so we already looked at these and we already had it set up to the point where we ended in example 4, where we had the matrix that had, is it 1, -1, 2, 9. Oops, that's not very straight. Let me try a little bit better there. And we had 0, 1, -1, -1, and 0, 0, 1, and 3. And we use this to solve. That's the Gaussian with back substitution. But Gauss-Jordan says I need to take these numbers here, and I also need to make them zeros. So we're just going to continue. All the work for the previous example would still apply here, but we're just going to continue from this point, so we don't have to rework all of that again. Alright, so what we're going to do first then is we need this here to be a 0. So let's see. To make that a 0, what if I added row 1 and row 2 and put it in row 1's place? So my next step here then is I'm going to take row 2, I'm going to add it to row 1, and I'm going to let that be row 1. So I'm not going to change row 2 or row 3, so I'm going to rewrite them. And so then I'm going to take row 2 and I'm going to add row 1. So when I take row 2, I'm going to have to write it on the side over here because I'm out of room below it. Now I can write a little bit below it. Alright, so when I take row 2, it was 0, plus the original row 1 that I just had was 1, and 0 plus 1 is 1. My second column, my row 2 is a 1. My original, so plus my original row 1, which is -1, which gives me 0, and that's what we wanted, so yay. And then same thing for the third column, take row 2, which is -1, plus what was originally in row 1 there, which is 2. -1 plus 2 is 1. And for the last column there, I have to do the same thing. So I had row 2, which is -1, plus the original row 1, which is 9, add them together, and we get 8. Okay, so now that we got that, we have this here. We need this to be a 0 now. So the only thing is, when I go to do this one, like I did once before in one of them, is I can't have the two numbers in front of it change. So I need, if I'm going to add or subtract something, I need to have zeros in those places. So I'm going to have to use row 3 to help me find my new row 1. So what can I do with row 1 and row 3 that would give me 0 there? Well, what if I subtracted them? Or I could say I could do a negative row 3 and add it to my row 1. So we could say then that row 1 minus row 3, but I'm going to put this as row 1. Now, because the way I put it, this is one reason I always put what it's where I'm going to put it there, because the way our book shows, or the way your stuff is showing online, it would have said take the negative of row 3 and add it to row 1, because they always put it whatever's listed last. But to me, it's just easier to see row 1 minus row 3 than have to change the sign of it or multiply by -1 and then add or subtract it. Alright, so we're not going to change row 2 or row 3, so I'm going to rewrite them. And let's see, so that's going to be 0, 1, -1, -1, and 0, 0, 1, 3. So now let's take row 1, what was originally there, minus row 3, and let's put that in row 1. So row 1 was originally a 1, for the first column, minus row 3 is 0, and 1 minus 0 is 1. So put a 1 there. For the second column, is originally row 1 was originally a 0, so it's 0 minus 0, which is 0. So we'll put a 0 there. Then for row, I'm sorry, I think I've been saying row, I meant columns. Column 3, R1 was originally a 1, minus R3 is a 1, and 1 minus 1 is 0, and that's what we wanted. So far so good. And then for the last column there, row 1 was originally an 8. Subtract out row 3, which is a 3, and we get 5 to put there. Okay, so now we got that. We've got one more place here we have to fix. Right there, that negative 1, it has to be a 0. It's not in my diagonal, and everything else on this side of that line that kind of takes the place of our equal signs. Everything on the left side of it has to be the 1s or 0s, and only 1's in the diagonal. All those are 0. So this needs to be a 0. So again, I don't want to change the first 2 numbers in that row. So I need to do something that has 0s on them. So it's going to have to involve row 3. What can I do with row 2 and row 3 that when I combine them, it's going to put a 0 in where I underlined there in blue? Well, if I add them together, that would give me a 0. Or, yeah, if I add them together, that'll give me a 0. So let's take row 3 and let's add row 1. I'm sorry, add row 2, and that's going to give me row 2. So let's see, I'm going to have to erase a little bit down here some of our work we did previously because it's kind of in my way. Alright, so I'm going to go to set this up. Let's see, I'm changing row 2, so I'm leaving row 1 and row 3 alone. So I'm just going to rewrite them. And let's work it out. I'm going to work it over here on this. No, I could work underneath again. So row 3 was 0, or is 0. And I'm going to add the original row 2, column 1, which is 0, and that gives me 0. Okay, for the second column, row 3 is 0. I'm going to add the original row 2, which is 1, which gives me 1. And then for the third column, row 3 was a 1. I'm going to add the original row 2, which is a negative 1, and 1 plus negative 1 is 0. And then for the last column there, I'm going to take the number from row 3, which is 3. I'm going to add what was in row 2, which is negative 1, add those together, and we get 2. So now we can see with what we've got there, we can see that we've got one x here, we have a y in this column, and we got our z in this column. And if you look this direction, those are the same numbers we just found in the previous example. So this one tells me that x, because there's no y and no z, is equal to 5. This row tells me there's no x, but there's a y, there's no z, so that y is equal to 2. And then the third row down there tells me there's no x, there's no y, but there's a z, and it's equal to 3. Therefore, I'm going to write this right up here above, so we get our solution set of 5, 2, and 3. Same problem, same answers, 2 different ways to work it.